Let's start off with the agenda for today's discussion. You have a face exam coming when exactly? Wednesday? Has it been finalized or Tuesday?
Wednesday.
Wednesday. So, what is the status now? Have you finished your what is the preparation with respect to both the topics, periodic properties and chemical bonding, right?
Yes, sir. Chemical bonding. I started doing questions. I finished theory. I'll revise again and continue doing questions again. But periodic table, I finished revising.
Okay, so periodic table is done more or less.
Yeah, mostly.
So let's start off with what doubts have risen. Is my voice clear, by the way?
It's clear, sir. Yeah, it's clear.
Okay, all right. So let's start off with what doubts have risen in your preparation as of now.
1 second.
Yeah.
Yes, sir. I had a doubt in a question.
Yes.
Yes, sir. The question is, in which of the following ionic compounds?
Send me the photo on WhatsApp. That'll be easiest. Let me download some JEE thing right now in the meantime. Give me a minute. Yeah, you send me the thing anyway, as usual.
Yeah.
Okay. A few questions, all right. Send me the set of questions which you have issues with. That's best. Yeah.
Yes, sir. I'm searching. That's it, sir.
Yeah. Give me a second. Just checking if I can see my screen clearly enough. So my screen is not visible. Right, you can't see my screen now?
Now I can't see it anymore, sir. I was able to see, now it's gone.
You can see now? The question has been put up now. You can see the question?
No, sir.
There is a problem then. Okay. 1 second.
No, okay.
Now it's okay. That's because I've stopped sharing. This thing doesn't do a good job when I'm sharing a window and sharing open board. I think now it'll be fine now. Now you can see, I suppose, yes?
Yes, sir. I can see it.
Cool. Let's start off then. So the second question was also posted now. Let me have a look at that. Okay, so the first one here. In which of the following ionic compounds, enthalpy of formation is negative only due to lattice energy? only due to lattice energy. Okay, so let's look at enthalpy of formation here quickly. So enthalpy of formation, what is that going to be for an ionic compound? Let's break it down first. What are the components here?
Ionization energy of the cation,
Mhm.
and then electron gain enthalpy of anion.
Is that it?
I mean, bond dissociation energy and all.
Yes. So add them. Let's talk about them. So you're going to be having bond dissociation for both systems. For let's say in each of these cases here, you'll be having 4 different scenarios over here. So it's going to be IE of sodium. So in case 1, it'll be IE of sodium, IE1. Dada is in class, lovely. Give me a second, dude. 1 second.
Yeah.
Yeah, it's cool. IE1 of sodium, and we are going to be having EA1 for fluorine, and we'll of course be having enthalpy of bond dissociation, that is metal bond dissociation. What do we mean metal bond dissociation here? Effectively, the metal has to be atomized. So what would be a better way of representing this? Instead of calling it as metal bond dissociation, what would be a better term there?
Atomized. Oh, I was thinking. Yeah.
You can call it for sodium and for fluorine. Fluorine chelate is going to be bond dissociation, obviously, because it's F2 breaking into fluorine atom, into half of it, of course. Okay,
Yeah.
so let's look at each of these here in terms of the values. This will be, of course, positive. This will be negative. These both will be positive, correct? Right. So this is going to be the rough case for all of them. Let's look at it for Li3 and MgO. It will be IE1 plus IE2 in those cases, right? And in some cases, it will also be IE3. But all of them are going to be positive anyway.
Yeah.
And if I'm considering, say, EA1, EA2, and in some cases, EA3, we're going to be having EA1 being negative, but EA2 and EA3 are going to be positive. That part is clear now?
Yes, sir. Yeah.
So why is EA2 and EA3 positive?
So because when you remove, so this is for, like when you remove an electron, you are, sorry, when you add an electron, sorry, my bad. When you add an electron, it's already in a stable place, so you need to provide energy for it to lose it.
What nonsense? No. Define what is, can you define electron gain enthalpy or electron affinity properly? What is the definition?
Electron gain enthalpy is the energy required or energy released when an electron is added to an atom. Yeah.
Okay, all right. If I'm looking at EA2, what does that mean?
When you add 2 electrons, when you add an electron to the unipositive.
So what does that really mean? Am I adding 2 electrons or am I adding the second electron?
Second electron to the uni-negative
okay.
atom.
So
Species.
How will that be? What kind of equation would you write down for that?
For some gaseous uni-negative ion, A minus plus E gives rise to A2 minus.
Good. So effectively, if I'm going to be considering it from the oxygen's point of view over here, it will be O minus 1 plus electron giving O2 minus. Now, why is the enthalpy change for this reaction positive? I'm telling enthalpy of this reaction is positive. Why? And you know it's positive, you got the data correct, but why? Your why was wrong.
Because when it is turning into an O2 minus ion, it becomes into a stable electronic configuration.
I'm telling you that is wrong. Stop thinking that way.
Okay.
let's talk about first why this is going to be better. Or if I take, say, sodium and I put an electron and I make an Na minus, I can say even for this, enthalpy of this reaction will be negative. Why? What is happening? If I add an electron to an atom, what is happening there? What is the premise at the starting? The premise at the starting is these two fellows are infinitely spaced apart. That is, the oxygen and the electron are infinitely spaced apart, correct? They are at massive distance away from each other, and we are bringing them closer together. And when the electron goes inside the atom, what happens? What is the electron's energy at the start? Zero? That's the general assumption, no?
Yeah.
Correct? Because it's an infinite distance from the
At
oxygen.
infinity, it's zero.
Nothing on it. The definition basically tells we assume they are at infinite distance and then we bring them together, correct? So if we are going to be looking at that, the start energy is zero. What is energy of electron at final stage, final state? Positive or negative? It's inside an atom, correct?
Yes.
If it's inside an atom, it is going to be experiencing more attraction
Repulsions and attractions.
Attraction and repulsion. But what is going to be greater?
Attraction.
Is keeping it inside, na?
Yeah.
Attractions are greater. So attractions are greater, na? Is it positive or negative? It has gone to a lower energy state. That is basically what is going to be energy released. You understand the funda here?
Oh, okay, yes.
So this is exactly what happens. So if I'm going to be getting an electron into hydrogen atom or H plus ion, if I'm going to be looking at H plus ion and I'm going to be looking at electron affinity of H plus ion, that will effectively be this electron and the H plus ion were at infinite distance, correct? If I'm asking what is the enthalpy change for this reaction? Enthalpy now, it is basically going to be nothing but a terminology which is used to mention this is going to be happening. That's all. So I think I made one mistake over here in assuming you know what delta H means, because I have started using that and you didn't correct me earlier. And stupidly, these questions seem to have delta HF there. So that is something which I suppose I can start addressing first. Did you understand what this delta HF meant?
Bond enthalpy of formation, right?
So you knew that terminology there then already. Yes?
Yeah.
Cool. Okay. So delta H basically means enthalpy change. From a basic perspective, because you have not done thermodynamics, let me just quickly tell you easy way of understanding what this means. This is nothing but heat change for process at constant pressure. When I say constant pressure, you can think of it as constant atmospheric pressure. Basically, it's an open box, all right, or a closed box. Anything, it doesn't matter where you do it. If you have a reaction happening inside a closed container or an open container where it is, having atmosphere outside, generally it is going to be considered as, not generally, it is going to be enthalpy change, which is going to be what you measure as the heat change for the process. So in this case, heat change, energy change for the process. There is another thing which I think there is a problem here, which I think is going to be in your brain already. I again have neglected that as well. Since you're a smart kid, I made the assumption that you might know this already. Let me quickly give you a quick recap of why I'm using plus and minus here and what is the meaning behind that. In chemistry, if I'm taking something which I'm observing, I'm going to call that as a system, let us say. Okay. The system is basically the name for whatever you're going to be observing in general. If energy is going out of the system into the rest of the universe, then we give this particular thing a sign of negative. If energy goes into the system, we will generally be giving the sign as positive. Effectively, it's the same thing which you have learned in your atomic structure. All of that still applies. This is just making it more crystalline. That's all. So as of now, I'm guessing you are following this plus and minus with a little bit of trepidation, I suppose, or with a little bit of little slowly. Now I hope things are getting a little bit more clearer for you. So this is basically the idea here. And when I say delta H of reaction, what do I mean? I mean whatever change I'm looking at, the enthalpy of that particular change. So if I'm looking at the enthalpy of that particular change there, the enthalpy is basically going to be heat change if that process happens at constant pressure. That's all. So if I have O minus accepting an electron and becoming O2 minus at a constant pressure condition, then you're going to be having electron gain enthalpy being the heat change involved in this change at a constant pressure condition. That's effectively how it goes. So I hope you got some clarity with respect to the random things which I threw around a little bit back. Now, it still is going to be something where we have not finished the discussion here. So let's go back to the discussion and continue there. So if I have H plus accepting an electron, if I look at delta H of this reaction, what is going to be the enthalpy change involved there? The electron's energy initially was 0, right?
Yes.
What is the final energy of the electron?
It'll be negative, right? Negative.
What is the value? In this case, you should be able to get me the value.
See. Wait.
So the electron in final state, where is it? In hydrogen atom?
In hydrogen atom, yeah.
Correct. So if it is in the hydrogen atom, what is its ground state? Shell number 1?
Yeah, n equal to
1. So if it's shell number 1, and this is going to be a single atomic species, single electron species, what can I apply?
13.6
So you're going to be having 13.6 electron volts. When you're going to be putting it as enthalpy, you will have to consider it as joules. So what is the value in joules, bro? What is the energy of the electron in the final state? 13.6 electron volt is correct. It is minus 1312 kilojoules per mole actually.
Oh yeah, minus yes. Yeah.
So you're going to be having it. This particular enthalpy change over here is going to be what? Minus 1312. Yep. Why? Because the electron went from 0 to this minus 1312. Correct?
Yeah. So the attractions release energy outside the system.
Not electron. This reaction will release energy.
Yeah, that's right. The system itself.
Correct. So the system where I'm observing this reaction happening will now release 1312 kilojoules of energy per mole of hydrogen atom being formed over here. That is the basic understanding over here. Now, we will go back to the original question. Why is this positive? You understand now, I suppose, that when the electron gets in, it is going to be gaining stability only, right?
Yeah.
Whether it gets into an oxygen atom or an O minus ion, electron's initial starting energy was 0, final energy will be negative. But this reaction's enthalpy change is positive. Why? What is happening in that reaction? Voice it out. What is happening?
Electron goes into the oxygen atom.
Oxygen atom?
Sorry, ion.
What ion?
O minus ion.
So what is the charge of the electron here?
Charge of the electron
here?
Sir?
What is the charge of the electron here?
-1. What?
Yes, and what is the charge on the oxygen?
-1.
So Have you ever looked at the interaction between these two species?
They're
Both are
repelling.
negatively.
Yeah.
What will happen if both of them are negatively charged? When you are bringing them together?
They'll repel.
Yes.
Oh, yeah, yes. Okay, got it.
Mhm.
Okay.
Explain then if you got it.
So since it's they're repelling, so when you bring them closer, you need to provide energy into the system. That's
Exactly
why
the
it's
problem.
positive.
Yes. Because these two guys are going to be repelling each other, they do not want to come closer. So to force them together, you will have to provide energy. But once it goes in, the electron becomes happy.
Yeah, okay. Yeah.
You understand the idea there? So once it gets in, it will release a tiny burst of energy, which will compensate for, what to say, nothing.
Stability.
It can't
Oh.
really compensate because the amount which you have to provide to push them closer is definitely greater. So put together, you'll end up having it being positive. That's the idea there. You understand the principle here?
So then why is my explanation wrong? Like,
Because it does not matter about stability. What was your explanation? You tell me your explanation again.
I said when the electron goes into the O minus ion, it gains stability. I mean, like, it gains stable electronic configuration.
No, you said it breaks the stable electronic configuration and hence it should be positive, correct?
No,
Is that not what you're thinking of?
I said it comes in, like at the end, it becomes stable electronic configuration.
Okay, so how does that help over here? In this case, O minus is not stable and the O2 minus is more stable. So logically, according to what you're saying, that should be negative. It should not be positive. It is gaining more stability. O minus 2 is more stable than O minus according to you, correct? Yes or no?
Yes.
So if something is becoming more stable, what does more stable mean? Greater energy or lesser energy for the system?
Releasing energy. Lesser energy.
Yes, less energy for the system. So why did I say it was wrong then? Because your logic can be construed in two ways. First, either you can construe it as, either you can say, you can think of, I mean, either this was what you said, where you mentioned it as stability is being lost, hence it should be positive, which is also wrong here. Or you mentioned it as stability is being gained, so it should be positive, which is also wrong. So stability has nothing to do with it. That's the problem there. The moment you bring in the term stability, your entire, it's like what to say, your direction itself is wrong. Your starting direction itself is going in the wrong way over here. So you should not even bring stability into the picture when it comes to EA2, etc. The only thing you have to start looking for is what is the interaction between the species. Now, why do you think it was wrong? Are you convinced? I don't think you are fully convinced, or at least. So your face doesn't show that you're fully convinced. What is your kujli jo baki hai? In a sense, what is left over in your brain is a small prick which is irritating you.
Like, why doesn't, like, stability should matter, right?
Stability will matter. Stability will matter. I'm not saying stability doesn't matter. Think of it like this. Think of it like this. Let's say there is a medication which you have to eat. It tastes horrible. It cannot be taken with water. It has to be eaten alone, and you cannot change the taste of it in your mouth for some time because that helps. I'm saying that helps. Let's say it's going to be, say, frog's legs mixed with, say, some salamander's thing, all made nicely. And you're supposed to get a ball of it and then stick it in your mouth and keep it in your mouth for 5 seconds and then swallow it properly. No drinking water, nothing. You have to stay with it for 10 minutes. After that, it will make you extremely strong. So after that, you'll be very nice. You'll be very stable, let's say. Whatever issues you had is gone. In the process of you consuming it, you're becoming more stable at the end of the day. But the kind of resistance which is going to be felt is going to be much higher in the beginning. Correct?
Yeah. Yes.
So, is talking about stability, which you're going to be getting at the end of the day, going to help me in convincing you completely? It will help me in convincing you, certainly. I mean, it depends on how logical you are and how old you are. For instance, for you, if I'm going to be giving it to you and I'm going to be telling you, eat it, it'll make you, make you more attractive to girls. There's a good chance that you might actually, if you remember correctly, you're familiar with who Joe Rogan is?
Yes. Yeah.
You know, Joe Rogan started off where? Where did he start off in his career?
I'm not sure.
He started off with eating scorpions and cockroaches and crap in Fear Factor, bro.
Oh.
Not even kidding. And there are people considering him as, and I do consider him also. He's a very incredible person. And look at where he had to start. If I tell you, eating cockroaches on TV for 10 days will basically make you a superstar and will make you attractive to a lot of people and will give you what you need. You know the end game is more stable,
Yeah.
but you'll have tremendous resistance anyway, right? So somebody will have to really push you into that. Or at least for me, somebody would have to push me. So the idea there is the pushing you has to be the factor which you really consider when you consider the overall change as a whole. See, what is chemistry all about? Chemistry is all about studying change at the micro scale. Anything which changes, we try to study it happening at a micro scale. So in this case here, when you're trying to study this overall change together, if I talk about only the stability, my logic is completely wrong here. Especially when I'm talking about this second electron affinity here. If I'm talking about the first one, yes, you're completely correct. See, it's like when there are two competing factors, chemistry is always going to be having multiple forces which are going to be acting on a system constantly. You will have to pay attention to which one is the critical one. And you remember the markers and the understanding which I talked about earlier.
Yes.
How it works is, in this kind of case here, if you keep a wrong marker in your brain, your problem is right now you have basically kept electron affinity, electron gain enthalpy, stability is a marker. Correct?
Yes.
I am saying that is not wrong, but you have to refine your marker over there. You have to refine it as electron affinity 1, stability is the marker.
Stability.
Electron affinity 2, repulsion is the marker. That doesn't mean stability doesn't apply. It means stability applies, but
lesser extent.
Basically, repulsion is more important.
Yeah. Yes.
You have to think about that as the main thing over here, as the dominating force here. So your markers have to be clean and refined as you learn more and more information. You can't keep maintaining the same markers. Your brain's markers also can change and will keep changing. You have to basically make sure you update your markers as and when you come across more data. This is data which you have come across, but because you had an older marker at play, you couldn't answer it correctly as to why. You knew the answer. Where will this hit you badly? This kind of thing will hit you badly in a more than one answer correct theoretical question. Yeah. If they're asking a good more than one answer correct question with theory behind it, this is the kind of thing which you will mark as what you thought is correct. And you will remember it as correct also, because the data which you remember is correct. That's not wrong. The reason is wrong. So if they ask a reason as one, if they basically mention the reason as one of the options, you will definitely end up making a mistake in that. And you will assume it was correct also till you see the key and till somebody explains it to you. That is the problem with chemistry. You can basically fool yourself into assuming things wrongly. You have to question the assumptions you make regularly, especially at this kind of a time when you are basically revising the topic again. Think of it like this. My chemistry got refined in 2 stages, I would say. I had a very good refinement when I was a student. And I ended up completely out of chemistry for like a long period of time. Then I came back into chemistry again when I started teaching it. So effectively, it's like when you sleep, the connections get made. So when you turn it off, connections start getting made over there. But sometimes you have to consciously change those connections when you get more data. This is one of those types of things where you have to consciously change the fact that, yes, electron affinity 1 ke liye stability is the main factor. For electron affinity 2, though, it is not stability which is the main factor. It is going to be repulsions which is the main factor. Not just for 2, electron affinity 3, 4, whatever.
Yeah.
Now, let's come back to this. So,
I have one more question.
Yes.
So, what's the difference between enthalpy and energy?
See, this is something which I will explain to you, but it will be better for you to learn it in thermodynamics. So, let me put it like this. Thermodynamics is basically the study of change in a system in a very mathematical, precise manner. And what to say, energy is like a superset of enthalpy. You can think of it like that. Enthalpy is going to be more or less, if I have to define it very exactly, you can think of enthalpy as this. Enthalpy is going to be, in the best possible way, you can imagine it like this: total energy available to a system. Total, na, absolutely total energy. Completely total energy available to the system, including energy invested by the system into occupying space. You will be learning this differently when you are learning it in your thermodynamics chapter. But try to remember this definition when you're learning that. It will help you when you're, thinking of enthalpy a little differently. Because enthalpy is effectively speaking this. If I'm going to be having, say, me as a system or you as a system or any system, let's say I'm taking a gas in a box. All right. There is some energy available to that, right? But at the same time, I have added one extra nonsense here. Energy invested by the system into occupying space. What do I mean by that? If I'm going to be having the gas occupying some space, if I have a gas in between my hands over here, let's say it's going to be a box over here. If I have a gas inside here, that gas is occupying this space. What do I mean by occupying this space? Think and tell. It's occupying that space against whatever is outside, correct? So if I take this box over here, this box is going to be something where, let's say, there's a gas inside. If the gas is present inside, let's assume that the box's surface is not there. It is something which is going to be, anyway, the box is anyway going to be outside, exposed to the atmosphere. So the gas present inside is actually occupying that space by pushing against whatever is outside. Which means it is investing some of its energy into that space it is occupying to occupy that space. Enthalpy is going to be including that energy also. So that energy is going to be the pressure it is against,
bombarding,
multiplied by volume it is occupying. That's the way to imagine it. You will learn this a lot more in detail later. For now, assume enthalpy is going to be giving you the net energy of a particular system. That's the best way to imagine it.
Net energy. Okay.
Oh, all right. Now, okay, where were we? The question is still not solved. We'll go back to the original question now. Which of the following ionic compounds enthalpy of formation is negative only due to lattice energy? See, there is a very poor question. All right. When I say it's a very poor question, why do I say it's a very poor question? Simply because the stupid question over here is always going to be having two things which are negative. What are the two things negative in all of these? In all of these cases, whichever enthalpy of formation we are considering, what are the two things which will be there which are negative? We have IE, which is always positive. Any bond dissociation is always positive. EA, if I'm going to be considering, or electron affinity, if I'm considering, the first one will be negative, but the remaining will be positive. But there is always EA1, which is negative. So I will always be having lattice energy, which is negative for sure. Lattice energy or lattice formation thing is always going to be negative in this case here, along with EA1 for all of these. So if I have to give an answer here, I would go with Delhi. Why? Why am I going with Delhi?
So,
this is a very basic JEE mains type of question. This cannot be asked in a JEE advanced type of setting. Why is because this is a very poorly phrased question. JEE advanced will avoid poorly phrased questions. Answer is either all of these or none of these.
Okay.
You understand what I'm saying there?
Yes, sir.
Because when they mention only due to na, the real answer is what? What is the actual correct answer?
There is no correct answer.
None of these. Why?
Yeah.
Because all of them will have one extra factor also. EA1.
Yes.
So, if I am going to be considering EA1 as not to be included,
Okay.
I should make sure I'm not including them in all of them.
Yeah.
In which case, answer will become all of these.
If we take a case where EA1 is positive, then it will also
Will
be.
I have EA1 positive in any of these cases?
No, I'm like in another case, not in these cases. But
When will EA1 be positive?
1 second.
When will it be positive?
For noble gases.
Good. So yes, when you're going to be having krypton difluoride as the compound they are asking, yes, you can say for this guy, if it forms a crystal lattice structure, in that case, that is going to be because of crystal lattice formation, lattice energy. I'll agree for this case. But if it forms a crystal lattice, I know for a fact this guy is a gas.
Oh.
So
Okay.
you're going to be having again lattice being again this case basically ends up becoming defunct again. So the question becomes a moot point, so to say. So in this case here, the best answer would be Delhi. What is the answer given?
C.
Then they have basically messed up the question by levels of magnitude. And what is the problem there in their question there? What
It's
should have
unclear.
been for it to be? No, let's try to make that question clear. That is also something which you can start working on now. Think of it like this. The answer given is 3. Answer given is C. How would you, what could be the correct question here then?
Okay.
What should have been the correct wording?
Okay.
That is another thing which you can train yourself with. Why? Because language is starting to matter. Especially in JEE mains and JEE advanced, language is starting to matter. Internal exams probably not so much. Because internal exams, when you're having every week exam, no teacher will have time to sit and prepare proper full papers by themselves and make new questions. It's just not feasible. They will only be circulating. I can say this honestly because I also will be doing the same thing if I'm required to prepare a question paper, because there is infinite questions under the sun. All we have to basically do is pick the good ones. And thing is, if you want to keep yourself updated to the new trends, because JEE, you will, especially advanced, you will not be facing the same questions you have seen. At least 10 to 15% will be new questions, new types, new ways of irritating kids. That's basically their job for a year. So in 1 year, a professor can definitely make 3 or 4 questions which are going to be frustrating for a child. Not a problem. Really frustrating for a child. So, in this particular case here, what could be the question then, if C is the answer? What looks like the difference between option 1, 2, 3, and 4 over there in the compounds there? In 2, 3, 4, the difference is that they are having EA2, EA3 also, correct?
Yes.
So,
Yes. Yeah.
a better way of phrasing this question to get answer as C would have been, in which of the following ionic compounds enthalpy of formation is negative only due to the lattice energy and
Disregarding.
not because of the combined electron affinity. If they could have mentioned that a little bit better, then they would have gotten the question more clean. But the problem is, this question was made by somebody with the intention of making sure it is ambiguous. That will happen quite often as well. So anyway, this is basically going to be something where if you want to make C as the answer, you'll have to mention that you should not take combined electron affinity, or you should treat electron affinity as a combined unit, not as EA1, EA2, EA3. If I treat them as EA1, EA2, EA3, then I end up having problems. Right? If I treat them as electron gain enthalpy of total, then what happens? Then answer C is correct.
Okay, yeah.
You understand the idea there? So for answer C to be correct, they have to mention at least one point saying treat electron gain enthalpy as a combined, system, not as individual pieces. That's the basic thing there. Now let's look at the second one.
So here,
Yes.
can you say anything like lattice energy is directly proportional to the product of charges, right? Could you say anything about that?
What do you want to talk about here? What do you want to compare here?
Like in the first case, the product would be 1. Second case would be 4, like that.
No.
No
In all
comparison like
four
that.
of those cases, lattice enthalpy is going to be quite highly negative. And that is going to be the main reason why all of them have enthalpy of formation as negative. That is definitely true. Main reason is lattice energy being negative. So that is why all of them are going to be having enthalpy of formation being negative. That is definite. But that is not the only reason.
Yeah.
So don't bother with but the question which you asked can be rephrased slightly differently. Let me pose that question to you. Which among these would have the compare the lattice enthalpies, lattice energies of each of these systems over here? How would they look like?
MgA would have the greatest.
Good.
And then Li3 and Li3n.
Then?
And then Na2s and then NAF.
There's an issue here. Where is the possible issue? Where is the possible issue? There is an issue.
So between 1 and 4?
No.
Then? The size also matters.
Okay. But that's not what I'm looking
at.
at.
The charge, right? Okay.
What happens with respect to Fajan's rules here? Consider that as a hint here to look for.
Okay. Small cation, large anion.
So which one is the problem here?
Sir?
Which one is the boogie here? Which compound is the problem? The problem will come with your Li3n.
Third one.
Lithium nitride is something which will have substantially higher covalent character than expected. And because it has got substantially higher covalent character, in fact, I would bet it is close to at least 40-50% gas pass over. What happens is its ionic nature has reduced tremendously. So if its ionic nature has reduced tremendously, automatically the fraction of charge which is present on each of those systems in KQ and Q2 by R squared. When you look at your energy, your lattice energy, it's KQ and Q2 by R related, correct? Not KQ and Q2 by R squared. That was a mistake. KQ and Q2 by R related. So if it's KQ and Q2 by R related, R value is not really the issue here, but the Q1 and Q2 are going to become much diminished here when your covalent character increases. Why? Why will Q1, Q2 decrease when covalent character increases?
when covalent character increases, the one second.
Charges decrease. That's literally what it means.
Yes, sir. Polarization happens.
So that's the reason why Q1 and Q2 end up decreasing here. Because Q1 is the cation and Q2 is your anion. So that decreases directly there. So when that decreases directly, this Li3N could be a boogie here. Na2S also has a possibility of a boogie here, of being a problem there. But what to say, Na2S I think will be okay. Should not be that much of a problem. It might be less than NAF, certainly. But what to say, it will not be having that much of covalent character as Li3N. Li3N will have substantially higher covalent character. So that is something which you have to think about when you are considering lattice energy as well. But ultimately,
the final order, what will?
I have no idea.
Okay.
See, when there are conflicting things, it is better to accept you do not know and find the data. My recommendation is, if you're interested in finding out, find the data. Now you know the logic which has to apply there.
Yeah, okay, I'll do that.
Apply the logic and decide which one, what to say, is best, and create your own marker for yourself in your brain. Basically, in this case, you can then create a marker, right?
Hello?
What would be the marker here? If, let us say, the order is going to be.
Hello? Yeah, you're audible, sir. Yes, sir.
I'm audible now?
Yes, sir. Yeah.
So if I'm going to be having, say, the order being, in this particular case here, let's say it's MgO greater than, say, Na2S greater than NAF greater than Li3N. What data can you lay down for your marker there?
Sir, can you repeat the order?
No, I'm just giving you a random order. I'm not giving you, this is the order type. I don't know the order, honestly.
Yeah,
so,
but like,
say the order is going to be MgO greater than Na2S greater than NAF greater than Li3N. What can you remember as a laying down point in your, for yourself in your brain? What should you remember? You should remember that when the charge is going to be increasing beyond -2, covalent character is something which you should start paying more attention to.
Beyond -2.
If it is like that. But if the order is going to be MgO greater than, beyond -2 is one thing. But also, what else should be the next thing? It is also about the fact that it is going to the next level there. It is going to be too small of a species, and -3 made is having problems. But if the order was, let us say, MgO, let's say the order was MgO greater than NAF, greater than Na2S, greater than Li3N. If this was the order, what would be your gleaning point then?
So here, if it's highly covalent, that means the charge will be less. So that's predominantly the point.
No. If this is the order, what should be your important remembering point there? What would be the key point, or that one piece of information which you can, what to say, remember as, oh, this has issues? What would be that thing? If this is the order, what is the problem there then? The problem is this guy is also lesser than the NAF, right? So what's happened over there is we are going to be having between these two covalent character plays. And over here also covalent character is playing a more critical role, right? But over here covalent character is not playing a critical role. Why is that happening?
Yeah. Because
you understand
it's highly
what's happening
ionic.
So you will have to start looking at things from a slightly different angle. In the sense, here covalent character starts playing a bigger role is fine, no problem. Let's tick that and get out. Here covalent character does not play a role. KQ and Q2 by R squared KQ and Q2 by R plays a bigger role. Fine, done. But what can be the key point which you can remember here? Covalent character is playing a role here, but you'll have to remember the why for this. Because if you know the why for this, or if you can make up a why for this, what could be a why for this? What could be a why? What's changed between the first and the third compound? Sodium and magnesium are okay, no problem, similar fellows. Sodium and magnesium are directly side by side, no issues there. What's the real issue here?
The anion.
Yep. So you will have to basically remember it as, oh, when I'm going from period this to period that, I should change the way I'm going to be looking at things. If I'm considering +2 charge systems, anionic systems, and I'm going to be considering period number 2, then KQ and Q2 by R is more important. But if I'm considering the flow on period 3, I'll have to basically switch into covalent character. That is how you have to basically create your own logic. I'm not saying this order is a correct over here. I have no idea what is the correct order. Let me be very honest over here. So depending on what you find as data, you will have to create your own way of remembering it in the most efficient manner. And you'll have to train your brain to, remember that piece of information, and you have to keep, solving a few questions which are going to be similar to that. And whenever you come across something of that sort, use that logic. Automatically, it gets imprinted as, understanding in your brain. That's the basic idea here. You understand how to proceed for this kind of a thing here? When you're comparing lattice energies, accept defeat. That's the real lesson over here. Accept defeat. There's nothing wrong with accepting defeat and getting data properly. So don't assume that you know. That is going to be a more criminal mistake than everything else. Let's come back to the second one here. Bond having highest bond energy. What do you think?
So the one with more electronegativity difference should have higher bond energy, right?
The one with more
electronegativity difference.
Okay. So what should be the answer here?
D.
Really?
Yeah.
Really? What's the mistake you have made here? I'm guessing this is your book and your scribblings on top, right?
Yes.
What's the mistake you have made there? I can say mistake bluntly in your scribbling. What's wrong? What's wrong?
Oh, carbon's electronegativity.
Yes.
Oh, okay. I got the question. No, sir. Yeah.
Next time, make sure you are remembering the electronegativity values properly.
Yes, sir. Okay. Yeah.
So
I don't know how I missed this.
Got it?
Yes, sir. Got it. Yeah.
So this guy is 2.54. So this delta En is going to be something like 0.96. This is 0.9 ke aspas, that is fine. In fact, it is slightly less than 0.9 because nitrogen is not 3. It is around nitrogen 3 to 3 is fine. 3 is correct. 3 is correct. 3 is fine. Nitrogen is correct.
Yeah.
So answer is C. Answer given is C, no?
Yes, sir. C. Yeah.
Okay. You got this guy more or less correct. You got the carbon there wrong. Okay, weird fellow.
Yeah.
All right. So effectively, you were in a rush, and okay, let's move on. Okay. Anything else? Any other questions you have come across? Any other concepts which you have had issues on?
Sir, can you explain electron affinity and electron gain enthalpy difference?
Okay. Okay. What is the electron affinity value for, say, fluorine? What are the numbers here? Let's compare them directly. What are given as the values? That's the easiest way of checking.
Okay.
You want to know what is the difference between them, no? Take
Yes, sir.
values. Take values, check. Whenever you are having this kind of a complexity arising, where it's a definitional thing, trust your own feeling and trust your own understanding to an extent. Don't worry about what to say, "Arey, mujhe nahi aa raha" type. You're a fairly smart kid. I can sense that you will not go in the wrong direction with this. So trust your own gut feeling about your understanding. Go get the data. What's the data for us? Get the data and give me the numbers. Or we,
minus 328.
Minus 328. What is given as minus
That's
328?
the electron
Check
gain enthalpy.
Google. I'm saying check on Google. Write it as electron affinity of fluorine and electron gain enthalpy of fluorine, and then check on Google.
Yeah, in NCRT it says electron gain enthalpy is minus 328 kilojoule
Good.
per mole.
Now go with the electron affinity. Check on Google.
Yeah, 1 second.
It's given as bluntly 328 or some other number which is like a small number, but it's given as a positive value, correct?
It's not loading, sir. 1 second.
Oh, you're still searching. Okay, let me just search over here then directly. That'll be easier.
Yeah.
Found
It
it?
says web page is not available.
You can see on the screen now, no?
Yes, sir.
So what's it given as?
3.45 electron
No.
volts.
No.
Oh.
What is it given as? Be very specific.
Electron affinity of fluorine is 3.54
Positive.
electron volts. Positive. Oh, yeah.
Positive, right?
Yes.
But this is negative.
Hmm.
Now tell me, what does it mean? What do you think could be the difference between them? Effectively, it's the point of view. That's all. You remember that system
Released
now?
and yes, sir. Yeah.
So this electron gain enthalpy is a professional definition.
Okay.
I don't know the exact spelling of professional, so I'm going to use whatever I can think of. So yeah, professional definition. So it's a professional definition in the sense this is after scientists had crystallized out what the subject has to be, how things have to be defined, and from a thermodynamics perspective.
Yeah, that's right.
So what was the perspective from thermodynamics point of view? That's the same thing which I mentioned about the sign convention a while back. If the system is taken, if energy is getting out of system, we will have to give it a negative sign. All right. But how is electron affinity defined? It is defined as energy released. You understand the problem here? So if I'm looking at EA1, that will be given as positive normally. But it is defined as energy released. So it is defined itself as energy released in the process. So they are not considering it as positive or negative here. This is before that positive negative sign convention came into being and started to be applied. So remember, all of this was stuff which was done by scientists, discovered by scientists as data. And simultaneously, scientists were also learning how to document the data and order the data. Different scientists, not the same people. So the people who were studying and getting these data points out, they defined whatever they needed to define to collect the data properly. Then a bunch of other people sat on this collected data and decided, oh, this documentation is not proper. This kind of documentation works better if I'm going to be collecting all of this data and then learning it. So electron affinity, you can think of it as an older definition which was used to define the same process. That is why if you look at the newer textbooks, they will all be not using any electron affinity. They will probably mention that term because older books used to use that a lot more. But nowadays they prefer using electron gain enthalpy. In fact, in your NCRT, which one are they using?
Electron gain enthalpy, sir.
So that's basically the issue here. So one is an archaic definition. The other is a more modern definition, which is basically going to be ignoring the scientists' feelings who initially collected the data and not giving a shit about what they thought and how they define shit, and is going with a more proper approach. For instance, look at India. You're a South Indian or a North Indian?
South Indian, sir.
So you being a South Indian, obviously prefer English as your main language of communication, right?
Yeah.
Why? Why is English most used worldwide, actually? Why do you think English became the standard language across the world? You've learned or you've heard that Sanskrit is a better language and all of that shit, correct?
Yes, yeah.
Right? We are Indians, man. We've all heard that rap. So I'm a Tamilian that too. So in my brain, it's like Sanskrit is like the other mother language. Tamil is the other mother language. English and all is bakchori. Don't even bother with that. Point here is, why do we not use Sanskrit? Why did Sanskrit die? Why is it that Tamil or other Indian languages, Hindi even, is not good? Why is English better? Why do we use English?
More people are familiar with the.
That is current market reality. Why did they start using English? Go to the true root of the question. Why did they start using English? Because Britishers went and conquered too many places. They started using because of that. Why did the Britishers start using English?
That was their mother tongue. Oh, was it?
That was not their main language. You remember Shakespeare and crap, right? Does that sound like, I mean...
Oh, yeah.
Is that what we use now?
No.
So why did they decide to switch into... Why? English is an ever-evolving language, by the way. What is the core principle behind English's evolution? Convenience.
Yeah.
Convenience of use. They do not care about things like, what to say, if you look at Sanskrit, it is such a messed up language. It is very good for goddamn computer programming, but it sucks for using in real life. Because humans are not fucking computers. That's the goddamn problem. In Sanskrit, there is like, there will be a different word when the sun is at this position, when the sun is at this position, that position. Every position of the sun, they have a new word for it. I mean, how many words can a person use for the sun? Sanskrit is a fantastic language for writing poetry, writing books, writing scriptures. Tamil is also, most Indian languages are fantastic languages for that kind of crap. But they are miserable when it comes to transactions between people, direct communications between people. It's the reason why English is used everywhere. And English is the most easiest language for communication in general. And that's basically what this comes back to as well. In the sense, electron gain enthalpy is a far more convenient definition for you to learn. A much better definition. But we have still not transitioned out of the old use yet. So the old use is still left over. Electron affinity is still left over. Some teachers, some question papers will purposely have the term in a misleading manner. You will have to understand what they mean and use it sensibly. When they say electron affinity and they're giving you the value as positive, you will have to use your brain. Oh, they have given me electron affinity of fluorine and they're given it as a positive value. Basically, that means they have made a mistake there. They should have given it to me as a negative value. You can assume it's negative and proceed the goddamn thing on the question. They make mistakes. Trust me. Teachers will use random statements. For instance, you might find in your exam that electron affinity of fluorine is given as 328. Or they can give it to you like this. Electron affinity 1 of oxygen is going to be 300. And electron affinity 2 of oxygen is going to be given as, say, minus 50 or minus 40. What does this mean? How should you interpret this?
So we just reverse the signs and assume it to be electron gain
Exactly.
enthalpy.
Exactly. You have to reverse them into what makes sense to you and then use them in your question. You understand what I mean?
Yes, sir. But it's not always negative, right?
No, EA2, when they're giving it to you as electron affinity 2, it is negative only. Now, what does negative here mean?
I want to
If
say
I'm
it's
saying
electron
energy released is negative, what does energy released being negative mean?
energy is going out.
Energy is
Oh,
absorbed.
wait, no.
Correct?
Oh, yeah. Absorbed, sorry. Yes. Absorbed, yeah.
You understand what this means here now?
Yes, sir.
So this is basically the same thing as what I was explaining to you. E8, what is it? Electron gain enthalpy number 2. You have to supply energy.
Yeah.
This is energy
Sir,
released. This is supplied.
Huh.
You understand what I mean by this?
Yes, sir. Yes. I got it. Yeah.
There's a possibility that, what is it? Depends on the teacher, obviously, who's setting the paper. There are questions where I have seen this confusion happening even in JE, for God's sake. So this nonsense, not anymore. Older papers, like say 7-8 years back, if you look at papers, there will be an interchanging between electron affinity and electron gain enthalpy once in a while. Sometimes they have asked frustrating questions based on this. So what is electron affinity? Electron affinity is literally nothing but the inverse of electron gain enthalpy. That's the easiest way to remember it. Minus of electron gain enthalpy is electron affinity. And electron gain enthalpy, what is the idea there? They are looking at it purely from the system's point of view. Energy in is positive, energy out is negative. Does that make your thing clear here with respect to electron affinity and electron gain enthalpy?
Yeah, I got it, sir. Yeah.
Okay. Any other issues in terms of theory which you have had?
No, sir. No.
Okay. So we have basically skirted past what was supposed to be the agenda for today's discussion. So let's move on to something else. I will basically end up doing this instead. What book do you have for your work on JE? You use the Fiji archive, or which archive do you use?
Sir, I finished Fiji archive, sir. But finished meaning I've done most of the questions.
Good. What are your doubts? Have you got doubts in that particular ones then?
Sir, a few I couldn't do because they were asking like out of syllabus stuff, I guess.
Best is this. If you're finished, you're marked on that on the book itself, correct?
Yes, sir.
Send me the photos. We'll quickly have a look at the pages which you have worked on. Instead of me downloading something and then checking out. I was supposed to have downloaded it earlier. I think I might have in my computer, but I don't know where it is. I can search.
So I haven't done all the questions, but only a few. Oh, I didn't do advanced.
Sorry?
Sir, I did the mains one, sir. I didn't do advanced.
You did only mains, is it?
Yeah, I just realized. Oh.
Okay, all right. So you have a reasonable number of questions left over to discuss. In the mains ones, what are your... send me the photos anyway. Let me quickly have a look at whether the doubts which you have got or whether your out of syllabus questions are really out of syllabus or not.
Okay.
Basically, your issue is you've got a bunch of questions that are out of syllabus. You don't know which ones are really out of syllabus now, correct?
Yeah.
Which phone do you have something which can take a good photograph?
Yes, sir. Yeah. It's okay.
Okay, good enough.
Yeah.
It's not Nokia Dabba model, no?
No, sir. No. Sir, I skipped a few repetitive questions, so.
I don't really care, bro.
Yeah, okay.
I'm just interested in seeing say really interesting ones or not. So yeah.
Yeah, sir. Simple. Oh. With the
Makes
Affinity
sense.
level.
Okay. A bunch of pages.
Yeah.
Okay. So let's have a look at which ones here. Fourth one is a problem or not a problem?
Not a
Fourth
problem,
one, I think
sir.
you already.
Yeah, I got it. Yeah.
Okay. Oh, dude, this is very pathetic, man. This is not a good book at all.
Yeah.
Have they not got any of the newer questions?
No, sir, they're still pretty old. They're like 2 to 3 like recent ones, but not in this one. In like other subjects, they're pretty
Crap, man. This is not a good practice for you. Sorry, but you have to practice newer questions.
Yes, sir. I have this PYQ book with me.
This is 2018, for God's sake. Fidji is giving this crap?
Yes, sir.
Seriously?
Yeah.
This is what they're calling archive now? Oh,
Yes.
you have to get a new archive, dude.
Sir, I have this one, sir.
Which one?
This one.
This is having which years, bro?
So this is recent. 1 second. Let's see the name. 2020 is there. 2021 is also there. I think till 2021 this is.
That is still not good enough, dude. Still not good enough. Dude, you're going to be... When are you writing the exam, you tell me?
Exam, which exam? Final or this phase test?
You're writing the actual exam when? JEE mains when?
2025.
Correct.
Yeah.
You should at least have data till 2023 then.
Yeah.
Get
Yes,
data
sir.
till 2023. This will help. This should have. I'm just not getting things properly here. I don't know what that book is called. So let me search for the book's name first and then get the thing done.
Yeah, I think I may have one. I have that, I think.
So it is called previous years. Okay, previous years.
2019.
This library Genesis will have pretty much whatever book you want. It may not have the immediate nearest version, but it will have more or less definitely. Why my net is not working properly here? Again, not searching in the correct place. Nora. Slightly older versions are available. You get a physical copy, dude. You get a physical copy because that is necessary.
I'll order that, sir. Yeah.
Stupid crap. So I will figure out how to get that book separately. I think if I go into that, I might end up inviting trouble onto my system here. So might as well avoid it a little bit. Okay. Where was that thing? Oh, this was here. All right. So let me look at the questions on my phone here. That'll be easier. Actually, what's happened to the exit now? Where was that? Yeah. So among the old questions, there will not be that much you would have had problems with, dude.
Yeah, I didn't have any problem.
They're all very simple stuff from what I mean. Up to the competition level has increased only in the last few years, especially in JEE mains. You've basically solved a bunch of nonsensically, okay, not irrelevant. They're good practice, certainly. The questions are not bad. You've skipped on 18. Why did you skip 18?
Why did I skip?
13 and 14. 14, you have a problem, I think. 14, you have to check the data. 13 is fine. If you're skipping, that's not a problem. 14, why have you skipped 14?
No, sir, I got this. I don't know why I didn't mark it though.
Okay, all right. And
So this 15th question, calcium carbide, is that CaC2?
calcium carbide is CaC2, and
Okay.
CaC2
Structure?
will be having a structure which is going to be slightly unique or not
Oh, I
unique.
remember. It's like a triangle kind of.
No,
Oh.
it is ionic.
Like all.
No, relax. It's calcium 2 plus and C2 2 minus. C2 2 minus is C
Oh.
triple bond C minus 1 and minus 1. Lone pair, lone pair. So it's called as calcium acetylide. I mean the technical name. Why is it acetylide? Because this is your acetylide anion. Meaning it comes from acetylene. Acetylene is C2H2. You remember C2H2, I suppose, yes?
Yes, sir. Yeah, C2H2.
So that C2H2 can technically act as an acid and end up becoming C2 2 minus plus 2H plus. So this anion is formed in that case. It's called as acetylide anion. Weakly acidic. Very, very weakly acidic. So these hydrogens are very weakly acidic. But they are acidic.
Yeah, got it, sir.
Why are they acidic?
So which?
Why do you think they are acidic? These guys are acidic, but C2H4 and CH4, these are not acidic. These hydrogens are not acidic. Why is it that this guy's hydrogen is weak, very weakly acidic? Why do you think?
So because it can lose the hydrogens right here.
Why?
Okay.
Why is it that this guy can lose the hydrogen more easily than the others? Or then when I say lose the hydrogen, it is willing to lose it. Why? Because the carbon, when it is in sp hybridization compared to sp2 and sp3, what is the difference? We discussed this a while back.
By
Not
different.
exactly today, some other day.
Yeah.
Which one is more electronegative?
Oh, electronegative is SPS. SP has most electronegative.
Why?
So because more S character.
Yes. And we had discussed also why S character matters earlier. I hope you remember that part. So effectively, this is the reason why this guy is having some acidic character. In the other two cases, C2H4 and C2H6, they are obviously not going to be having an acidic character because they are sp2 and sp3, which are not as acidic because they are not as electronegative. That's the basic reason. Anyway, okay, all right. So let's look at the questions again. So 18, why did you skip? What was your issue with 18? Let's have a look at which options are your problems there. 1 and 3.
Yeah, 1 and 3, yes.
Okay. So let's look at 1 first. 1 is doable. 3 also
Wait,
technically
actually,
is 3 probably, yes, I can say it is not doable right now. But 1 is partially doable. What does oxidizing power mean?
wait, I think it's correct. Sir, isn't PB4 plus a good oxidizing agent?
Why is that a good oxidizing agent?
Sir, because it wants. Okay.
What do you mean by that? Why does it want to? Why does it want to? It wants to because of a particular
Because
reason.
PB plus 2 is more stable than PB plus 4.
Why?
Inert pair effect.
Good. That's the actual excuse which I was looking for. So yes, you're going to be having this option. First option is correct over there. Mainly because you're going to be having the PB plus 2 being more stable compared to the PB plus 4. Inert pair effect, certainly. What is inert pair effect? Define, please. And where does it start clicking in from? And where do you have to stop looking for it from? Do you
Sir,
understand what I'm asking for as a question over here?
Yes, sir.
What's my question? Describe it in your own words.
You're saying when is it applicable and when is it not applicable, and like, why is it?
Why is okay? Why
What
to
is-
I'm assuming you understand the why. Right? No problems with the why, or you have a problem with the why?
So what do you mean by why again? Why what?
Why is inert pair effect happening?
Oh, yeah, I know.
You obviously have no issues with that, no? Lanthanide contraction, all of that is fine,
Yes,
correct?
sir. Yeah, that's fine. So, yeah.
So now what should be the marker which you lay down in your brain with respect to inert pair effect? Do you now understand what I'm asking you?
Yes.
So if you know the place where inert pair effect starts to be important from and where it ends to an extent, that becomes your marker. You understand what I mean by marker?
Yes, sir.
You can automatically start remembering that as a point in your brain.
Every time it comes, you can.
Which will automatically end up becoming understand. And you don't need to remember data about inert pair effect after that. So tell me, roughly, where will inert pair effect start working from? In the
After
periodic
the lanthanoids.
After the lanthanides, good. That means immediately after which group?
The deep block. Oh, group. Oh, 1 second. 12th
Give me.
group. 12th group.
Let's look at it as 1 to 18.
Yeah, after the 12th group. So 13 and onwards.
Really?
Oh, after lanthanoids, right? So after the fourth group.
Good. So it starts from group 4 on which period?
Period 6th and 7th.
Good. So period number 6 and 7 or 6 mattuma?
6 is there, but
see, that contraction will happen because of the 4 of being pathetic and the 5 of being pathetic. But what is inert pair effect going to be influencing at the end of the day? Inert pair effect basically influences trends down the group, across the period, those kinds of trends, correct? Which one is it going to be affecting more? Does it affect across the period more or down the group more?
Across the period.
Really? Really? Inert pair effect, will it apply for, say, bismuth? Where is bismuth?
Fifth period.
I literally given you where it is. Right before lead. Sorry, right after lead. Sorry. Right after lead. Damn it. Yeah, right after lead. So you're going to be having this over here right now. So if you're going to be having it right there, effectively the idea here is both of them are having inert pair effect active on them, correct?
Yes.
If I take the fellow before lead, what does that get? Lead is carbon family, right?
Yes.
What is on boron family?
Oh, 1 second. Oh, yes.
What is
thallium,
that?
Yes. Thallium.
Good. So effectively, now tell me, is inert pair effect active in this group,
Yes.
and this group?
Yes.
Right?
Yeah.
So is it active across a period?
No, it's not. No.
Where is it active more? Where do you have to watch out for it?
In the groups, like the
Correct.
one preceding below it.
So what is going to be happening because of inert pair effect? Because of inert pair effect, you're going to be having group may IE values are going to be messed up. Group may you'll end up having atomic sizes suddenly becoming smaller, which is why ionization energy gets messed up. In this case, for instance, boron group may, what is the ionization energy 1 value? Trend for boron group.
Decreases as you go down.
What's the trend? Give me the full trend.
It decreases till thallium and then
You're
And
gonna
then
write an
increase it.
exam soon on this. Give me the exact trend. Give me which is maximum. Give me the next highest. Give me the trend.
Oh, okay.
Hmm.
So boron will have the maximum,
Mm-hmm.
and then below that, aluminum.
You don't know? I have a homework for you now. Find the trends of ionization energy in all three of these periods, in all three of these groups. IE1.
Okay.
It's easy to find.
Oh, 3D, 5D will be greater than 3D will be greater than 4D.
That is 5D greater than 3D greater than 4D is
Yes.
D.
Oh, for D block. Oh, sorry. Yes. Yeah.
That is before this guy. That is correct. I have no doubts about that. You got that part correct there. This is perfectly correct. Now my issue here is till where? This is because of inert pair effect, correct? Yes or no?
Yes, sir. So till thallium it will go, and then it will the next one indium will be less than thallium.
I want you to find out. Find out. How difficult is that going to be? You tell me.
Okay.
Where do you have to find the data here? NCRT में कहीं पे होगा?
Google. Yeah.
खोदो. NCRT में खोदो. Find, search it in that. Search it. Get the data. Once you got the data, then take. You'll automatically start getting your markers when you compare the ionization energy values here. And if you want to go one step further, you can check for the next group as well. Oxygen ka bhi check. You will find something interesting. Inert pair effect will start decreasing when the shielding starts becoming better. What do I mean by shielding starts becoming better here? What is shielding?
So the number of electrons in the in the p orbital will increase, right? So
all of that is fine. Okay, chalo, away. Let's not go into shielding beyond a point. That is going to be, I can sense, it's a longer conversation maybe. We will talk shielding. When is your exam again?
Wednesday, sir.
Wednesday. When do you want to have the next session? I don't want to have a session on Wednesday. That we'll have it before Wednesday then. When do you want to have the next session? Ideally, I would prefer it after your archive of JEE advanced questions are worked up to some extent and you got some more questions.
Okay. Okay, sir.
So when would it work? When would be ideal for you? Because your preparation has to happen simultaneously also. So when would work for you?
So tomorrow evening is that fine?
Tomorrow evening. Tuesday early morning, would that work?
Sir, I have school, sir. I won't be able to.
Seriously?
Yeah.
They're not giving you a holiday?
No, tomorrow's a holiday.
Exam.
Day after tomorrow's no holiday.
Sorry?
Tomorrow's a holiday. Day after tomorrow's not a holiday.
Face exam ke liye they are giving you no holiday?
Oh, no. They're not giving any holiday, no.
Normally Fiji does, na?
No, sir. They haven't given for last phase. This phase also they're not giving.
Seriously?
Yeah.
Hey, man. I mean, yeah, it's been a long time since I have been associated with them, but okay, so they have become a little bit more tighter here at least. Okay, chalo, so you don't get a holiday on Tuesday then. So
No,
that is a mistaken assumption. Okay. Tuesday evening, you'll have to obviously finalize your prep then. There's no escape there.
Yeah.
Face exam is afternoon or evening?
Morning, sir.
Okay.
2 papers, full length advanced paper.
Full length advanced paper. Oh, proper official JEE advanced style ka you'll be writing there. 9 o'clock.
Paper 1, paper 2. Yeah.
Nice. That's good practice. Okay. Tomorrow evening, what would be ideal for you? What time would work for you?
Around 7. Is that fine?
You have some other class usually, no? On Monday.
Yes,
What do
sir.
you have normally?
So I think maths. Yeah.
You won't be having that tomorrow, or you will be having that tomorrow?
I will be mostly having.
Then how do we do this then? You're not Lord Krishna who can be in like one place and the other at the same time, huh?
Yeah.
So let's figure out something else then. Your max class normally is at what time tomorrow?
Sir, since tomorrow's a holiday, I guess I can put it earlier.
Oh yeah, holiday lah. Oh yeah.
Yeah.
Then you can adjust obviously. दो class तुम आ सकता है, कोई issue नहीं है then. हाँ. Then हाँ ठीक है. Let's do this then. Let's keep it floating for now, because I don't think you will know for sure when you will be putting in the time to practice the questions.
Yeah.
So once you are done, message me. I am also free anyway tomorrow. I'm also on holiday. What the hell? Yeah, I forgot about that. Yeah, मेरा भी कल छुट्टी है. So whenever will work, evening will work. I have no problems. Do you want a session before your face exam, or what do you feel?
Yes, sir. Sir, is it possible if you could take 1 hour? Like,
No problem.
so
I have no issues.
yeah.
It doesn't have to be a long thing, man. Basically, I want to make sure that what to say, any doubts which you get before your face exam, we can iron them out.
Yeah.
Hmm.
That'd be
So,
nice.
all right. So let's continue on with this now. So in this particular case, then I want you to check this. I want you to actually find the data for these three. That will become your marker, because you will start realizing it doesn't work fully. When I said shielding is increasing and shielding will stop the inert pair effect, what did I mean here? In the case of thallium, for instance, you will find that it will follow the general order. Boron, then you'll have thallium, then you'll end up having the order there. All right. So when you end up having this particular type of, after thallium, you'll have gallium, which is approximately equal to aluminium, which will be greater than indium. This is going to be your order for this particular group. In the case of lead, it will be slightly different. In the sense, it will still be the same, more or less, but it will have some small interchanges there. Go find out what is the change between the lead and the bismuth there. There you'll end up having something very interesting. In this case here, if this is the correct order here, this is the correct order for boron family. What does this trend tell you? Is it following inert pair effect, or is it not following inert pair effect?
It is.
Good. So this is still following inert pair effect perfectly. Even lead will still follow inert pair effect properly. Bismuth, you will end up having a slight interesting thing. Why that will start happening is because as you proceed from here to here, as you keep moving in this direction here, what is happening at bismuth stage? Bismuth ke liye, what are the electrons that are shielding? What is shielding the valence electron in bismuth?
So the f orbital and the d orbital
and what is the best shield for it?
Oh, s orbital.
S sir? No. What is shielding? It goes back to that unfortunate question. What is shielding?
Shielding is like the repulsion between the electrons, right? About them.
What do you mean by that? Oh crap. Okay, chalo. There should be some shapes on this. Okay, chalo, I am not having the patience to sit and find shape. So let me just draw the thing here directly. Chalo, I'll try drawing better. Okay. If I have a system like this, all right. What is shielding? Let's say I'm going to be having an electron about to enter. This is the last electron which is about to enter.
Yeah.
What is shielding for this electron? What do you think that is? Your definition is attracting. I want you to crystallize what you are basically thinking. You're not wrong. Your thought process is correct here. Crystallize it.
So
refine
the
it a little bit.
the nucleus is pulling the electron, but then in the way there are the electrons which are blocking it pretty much.
Good. So which guy is blocking it more?
S.
Don't think SPDF now. That is the next stage of thinking. Which guy is blocking it more?
The innermost.
Really?
No, the outermost.
Why?
Second outermost.
Why?
They're more. Oh. What distance is this?
Yes. What does this blocking mean here? It's nothing but KQ and Q2 by R
Q1,
squared.
Q2 R. Yeah.
R squared or whatever it is. It doesn't make a difference which one it is ultimately.
Yeah.
But it is something related in that direction, correct?
Yes, sir, yes.
So what will be the one which matters more now? This R. When is that R going to be lesser?
For the outer shells.
Exactly. So which guy is going to be shielding the bismuth's valence electron to the best extent? Which is its biggest shield?
Bismuth. 5F. 5P.
The thallium and lead's 6p electrons.
6P, exactly. Yeah.
All right. So 6p is going to be the main shield for the bismuth. So what will happen to the inert pair effect? Its effect will still be felt, but it will be diminishing. It will be diminishing as you go across the period here. So when you move from thallium to lead to bismuth to etc., the effect of the inert pair effect will keep decreasing there. It will keep diminishing.
Yeah. Yes, sir. Got it.
That is why I said there is a marker there for you to basically pick up on. Do you understand what I mean by the marker there now? So yes, that is going to be the point where your, shielding from the p orbitals overcomes your inert pair effect to some extent. Now, do you understand what I mean by a marker?
Yes, sir.
Yeah. So the marker in your brain here is going to be that piece of information which is going to be telling you, okay, up to bismuth or up to lead, I will remember inert pair effect matters more. After the lead, I should start thinking that shielding is something which also has to come over here. Meaning if I am getting a question on nitrogen group, ionization energy, order or something of that sort, I need to know the data better. You understand what the marker becomes over here? You'll have to basically look up the data for nitrogen and oxygen family. I don't remember the data. The reason why I do not remember the data is because there's a marker there.
Okay.
For everything else, I know inert pair effect will work. Up to lead it will work for sure. Bismuth, I will have to check up the data and then only actually, make a decision on whether inert pair effect properly works there or there is some controversy there. My gut feeling tells me there is a controversy there because I do not remember the data, or I think I should remember the data. And I feel like I've forgotten. So my suggestion here is go check out the data for nitrogen family ionization energy 1, oxygen family ionization energy 1. That will be something which will be, giving you some extra information there. Compare it with boron and carbon families, IE1. This will be available in your NCERT, of course, but not in this chapter, in different chapters. One warning I should give you here. This is a base exam, correct?
Yeah.
You will find that in this paper, they will ask you unnecessary questions from other parts of inorganic. You will get that. I would say 2 questions at least per paper. Do not trouble yourself with wasting time too much on those questions. You will get those questions when you are doing those chapters in inorganic. If it's a teacher who is who is going to be irritated and is purposely setting the question paper to irritate, they will do that. FitGMA, I do not know how the system is now. It might be nicer, but I do remember enough to know that the face exam will not be set by your own teacher.
My teacher's making the paper this time.
Oh, really?
Yeah.
Oh, then you're going to get very lucky then.
Paper 1 though, not paper 2.
Okay.
He told the paper is going to be lengthy this time.
Oh, he's already given you guys, it's going to be painful.
Yeah, so it's gonna be lengthy.
Then your more than one answer correct questions are going to be like each one is like a question. Then each option is like a question. Then
Yeah.
good luck. All right. Oh, it's already way past. When did we start? 2:30, 2:40. We should have started, no? So, all
240,
right.
yeah.
So this is enough for today. Then it has been not a productive session, I would say, because we have not discussed enough questions. But I hope it has been useful for you in terms of how to basically approach your questions and what are the other points of view you have to basically pay attention to. I would say your preparation is quite good. Not bad. Not bad at all. I'll have a look at the other questions as well. Just give me a minute. I'll just quickly have a look at the remaining questions to see if there was something else interesting which you have skipped on. Shortest bond length, I think you don't care now. Highest bond order you have mentioned. So you basically already understood that. Isoelectron is not a problem. Charge by size, okay. Which of the following exhibits diamagnetic, paramagnetic enthalpy? You're familiar, I suppose, yes?
Yes. Yeah.
Not a problem, na? Basically, I've skipped those questions because they are meaningless, right?
Yeah.
Okay, all right. Mm. 33, make sure you're having a look at it because calcium carbide, you had an issue just a while back. Solve 33. Is that related to this topic?
Yeah, that's what this was one of the questions I said I think was not a part of syllabus.
That is not really necessary here. 39 is important. You definitely have to. What is the answer for 39?
Give me a second.
What is the answer for 39? No, your answer for 39.
Yes, sir. Yeah.
Another question which I do have, which is more stable? N2 plus 1 or N2 minus 1?
So for that, you'll have to see bond order, right?
Both have same bond order, dude.
Oh, yeah, that's true. Yeah. So then the number of electrons in anti-bonding and bonding.
Good. So you got that logic there. I just wanted to confirm you remembered that or you knew that information. Okay. All right. Now 39. What's your answer?
SH2.
Why? What's
So
the bond
because
angle approximately?
H2, so 91.8.
Good. So you remember. Okay. I just want to confirm you know the data there approximately. H2S sulfur will have a bond angle closer
There
to
is no
9.
hybridization.
Yes, the hybrid. Don't call it as there is no hybridization.
Less effect.
But yeah, fine. It's okay how you remember it. It doesn't make much of a difference as long as you remember the data enough. So it's approximately 90 odd. So yeah, cool. Okay, all right. The remaining, that's the only thing which I want to confirm. All right.
So you can use the rule of that bond angle is directly proportional to S character and inversely proportional to lone pair here, right?
all of that is fine, dude. But
What would be
when
the
you
better way?
end up making up a logic, you have to be very clear where all it will work, where all it will not work. So I prefer to avoid too many unnecessary logics. If you end up having
So
too
here,
many things which you think as a logic now, the assumptions which you're making will cause trouble sometime. Like
so
the
here
electron.
H2S doesn't have any hybridization.
Okay.
So H2S doesn't have any hybridization and bond angle is directly proportional to S character, right? So does that have anything to do? Like you'll have less S character because there is no hybridization at all. Does that have anything to do with it? Is that a valid reason? I mean,
How about bond angle here?
it's 3.
If I ask you to compare these two guys,
So pH would have more.
And why? Is it having hybridization?
No, it does not have hybridization.
Then how do you compare these two?
The geometry.
Get your problem now?
Yeah, okay. Understood. Okay.
So avoid those kinds of facts.
But in this case, the rest are
Check
hybridized.
out the data. Never ever assume that a
Okay.
logic which you know will work everywhere or in as much scope as you want, because that is the problem with chemistry. You have to be fluidic. You have to accept in your brain things are not going to work.
Yeah.
Things are not going to work. You will be having no unified logic which will work properly everywhere. And the logic which will be given to you will be dependent on the level of competence the teacher wants you to basically achieve. And you must understand, beyond a point, accepting there is no logic is the best way to go. If you ask your teacher will probably not remember the data like this is unhybridized. If you have to ask them to compare H2S and pH3, they will not compare it in the point of view of ye tha. They will know data, and then only they'll give you an answer if they are giving you an answer. I will not give you an answer here. Why? I do not know the data.
Not data. Yeah, you could be wrong.
So I am not going to be assuming I know the shit here. I know both of them are very close to 90.
Yes.
But I don't know which is where. And if I make up some excuse to basically remember it, I will have something conflicting in my brain saying both should have equal bond angle. Do you understand where I'm basically pointing out your issue is going to be over here? According to the logic, you know, what should be the answer here?
You won't get an answer. I mean,
what should be the answer? This should be the correct answer.
pH3. Yeah, equal to. My bad. Yeah.
So equal should be the logical answer according to what you basically said, no?
Yes. No, both don't have hybridization. Yeah.
That is where you will have to basically make sure you know where your limits are going to be in any logic. If you remember a logic, okay, no problem. But remember, it is a logic which is
yeah.
And there will be a part where it will break apart. Fair enough?
Yes, sir. Yeah.
Go check out the data for both of these. It will be useful because there's a good chance if your teacher has mentioned this kind of logic, there's a good chance they might make a question based on something along these lines. Check out for hydrides of group 15 and group 14. I mean, group 15 and group 16 bond angles. Check that data out. Group 15 and group 16 hydrides bond angles. That is H2O, H2S, H2, what is it? Sulfur, oxygen, sulfur, selenium, tellurium, and
polonium.
Polonium to waste of time, chodo. And ye wala check karo. This will be also something which you need to remember. Remember the data to some extent. You don't need to remember the data as this. वो नहीं चाहिए.
The trend.
Trend निकाल के you remember them. That is necessary. Nitrogen, phosphorus,
arsenic, bismuth.
So in this year, up to BiH3, try remembering. I mean, try getting out the values. You'll be able to get them right comfortably. So if not the net, there are books available anyway. I will send you one of them, I think. I'll send you a fat book. I generally like following that. I'm quite sure your teacher might also end up following that type of a book. It is a very voluminous textbook. What does your teacher recommend for inorganic chemistry in your
Sudarshan Guha. Sudarshan Guha, JD.
Sudarshan Guha. Not bad. That's a decent book as well. It's a good book. It's not a bad book at all. You can use that. But I would recommend a little bit, if you're interested in more data, something which has more data available, you can download. I'll send that book to you. I will have that book anyway. I'll send that book to you, soft copy maybe. That will be something which will be more voluminous. It will have a lot more details and a lot more data though. where and you can trust the data on it a little bit more. Not a little bit more, on a similar level as Sudarshan was. I would say that much at least. So, all right. So in this particular case here, I think we can close things today here now.
Okay.
Any further doubts, do get them settled tomorrow. Tomorrow we'll keep it crisp for a 1 hour session. Send me the questions just before class.
Okay, sir.
What time do you want to have it tomorrow? You can decide based on your preparation.
Okay, sir. Yeah.
And your practice.
Sure.
All right. Anything else?
Okay, sir. Yes, sir.
Bye-bye.
No, sir.
See you. Good luck with this
Thank you,
exam. Good luck with your
Yes, sir.
preparation.
Thank you, sir. Have a nice day.
Bye.
Bye.
Have a nice day, dude.
Yeah.